An underwater volcano, also known as a submarine volcano or seamount, is a geological phenomenon where magma from beneath the Earth's crust erupts underwater, forming a volcanic cone or ridge. This process, while similar to the formation of terrestrial volcanoes, occurs within the oceanic environment and has significant geological, biological, and ecological importance. Geological process of underwater volcanoes. Magma formation. Underwater volcanoes are typically formed at mid-ocean ridges or hotspots where tectonic plates diverge or converge. In these areas, magma rises from the Earth's mantle due to heat and pressure, forming a magma chamber beneath the ocean floor. Eruption. When the pressure in the magma chamber exceeds the overlying rock's strength, magma erupts through a vent or fissure on the ocean floor. The erupted material, called lava, cools rapidly in the cold seawater, forming volcanic structures such as cones, domes, or calderas. Volcanic activity. Over time, repeated eruptions build up the volcano's structure, creating a prominent feature on the ocean floor. Some underwater volcanoes may reach the ocean surface and form islands or seamounts. Significance and importance. Geological processes. Underwater volcanoes play a crucial role in the Earth's geological processes. They contribute to the formation and movement of tectonic plates, influencing continental drift, ocean basin formation, and seafloor spreading. Mineral deposits. The minerals and metals released during volcanic eruptions contribute to the formation of valuable mineral deposits on the ocean floor. These deposits include sulfide ores rich in copper, zinc, and other metals, which are of interest to mining companies. Biodiversity hotspots. Underwater volcanoes create unique habitats that support diverse marine life. Hydrothermal vents associated with volcanic activity release mineral-rich fluids, supporting chemosynthetic ecosystems where organisms thrive without sunlight through a process called chemosynthesis. Oceanic circulation. Volcanic activity, especially near mid-ocean ridges, influences oceanic circulation patterns. Hot water release from hydrothermal vents affects seawater temperature and composition, impacting global ocean currents and climate systems. Natural hazards. Despite their significance, underwater volcanoes can pose natural hazards such as volcanic eruptions, landslides, and tsunamis. Monitoring and studying these volcanoes help scientists understand volcanic processes and mitigate potential risks to coastal communities and marine ecosystems. Scientific research. Underwater volcanoes serve as natural laboratories for studying Earth's interior processes, including magma formation, crustal evolution, and geophysical phenomena. Research conducted at these sites contributes to our understanding of planetary geology and volcanic activity on other celestial bodies. Tourism and education. Some underwater volcanoes, particularly those near coastlines, attract tourists and researchers interested in exploring marine environments and volcanic landscapes. These visits promote scientific education and awareness of marine conservation issues. In conclusion, underwater volcanoes are dynamic geological features with significant implications for Earth's geology, biodiversity, natural resources, and scientific understanding. Studying these volcanoes helps us unravel the complexities of our planet's processes and enhances our ability to manage natural hazards and sustain marine ecosystems. Climate influence. The gases released during underwater volcanic eruptions, such as carbon dioxide and sulfur dioxide, can impact Earth's climate. Large volcanic eruptions can inject aerosols into the atmosphere, leading to temporary cooling effects by reflecting sunlight and altering atmospheric circulation patterns. Ecosystem services. Underwater volcanoes provide ecosystem services such as nutrient cycling, carbon sequestration, and habitat creation. Marine organisms living near these volcanic sites contribute to global nutrient cycles and carbon storage, influencing marine productivity and biodiversity. Technological innovation. Research conducted at underwater volcanoes drives technological innovations in marine exploration, remote sensing, and underwater robotics. Technologies like deep-sea submersibles, autonomous underwater vehicles AUVs, and seafloor mapping systems enable scientists to study and monitor volcanic activity in remote oceanic regions. Resource potential. Beyond mineral deposits, underwater volcanoes hold potential for renewable energy sources such as geothermal energy and methane hydrates. Harnessing these resources in a sustainable manner could diversify energy portfolios and reduce reliance on fossil fuels. Cultural and historical importance. Indigenous cultures and societies often have cultural and historical connections to underwater volcanic regions. These areas may hold spiritual significance, traditional knowledge, and archaeological artifacts, highlighting the intersection of human heritage and geological processes. Global collaboration. Studying underwater volcanoes requires international collaboration and cooperation among scientists, governments, and stakeholders. Collaborative research initiatives promote data sharing, best practices in marine conservation, and sustainable management of oceanic resources. Education and outreach. The exploration and study of underwater volcanoes inspire public interest in earth sciences, marine biology, and environmental conservation. Educational programs, documentaries, and outreach initiatives raise awareness about the importance of oceanic environments and the need for responsible stewardship. Environmental resilience. Understanding the resilience of marine ecosystems to volcanic disturbances contributes to conservation and restoration efforts. Monitoring changes in biodiversity, ecosystem structure, and ecosystem services helps assess and mitigate the impacts of underwater volcanic activity on marine life and habitats. In summary, underwater volcanoes are multifaceted natural phenomena with far-reaching implications for Earth systems and human societies. Their significance spans scientific research, natural resource management, climate dynamics, cultural heritage, and environmental resilience, highlighting the interconnectedness of geological processes and human interactions with the oceanic environment. Risk assessment and management. Continuous monitoring and assessment of underwater volcanoes are essential for risk management and disaster preparedness. Utilizing advanced monitoring technologies, such as seafloor sensors, satellite imagery, and seismic networks, helps identify early warning signs of volcanic unrest and potential hazards, enabling timely evacuation and response strategies. Policy and governance. Effective governance frameworks and international agreements are necessary to address the complex challenges posed by underwater volcanic activity. Policies related to marine conservation, resource exploitation, environmental protection, and disaster risk reduction should consider the unique characteristics and impacts of underwater volcanoes on ocean ecosystems and human communities. Sustainable development. Balancing human activities with the conservation of underwater volcanic regions is crucial for sustainable development. Integrated management approaches, incorporating scientific knowledge, stakeholder engagement, and ecosystem-based principles, can support the sustainable use of marine resources while safeguarding ecological integrity and resilience. Adaptation and resilience building. Communities and industries located in coastal and island regions near underwater volcanic areas must develop adaptive strategies and resilience building measures. These may include land use planning, coastal zone management, infrastructure design, and community awareness programs to mitigate risks and enhance preparedness for volcanic events and associated hazards. Future research directions. Ongoing research on underwater volcanoes should focus on interdisciplinary studies, including geology, oceanography, biology, chemistry, and social sciences. Key research priorities include understanding the long-term impacts of volcanic eruptions on marine ecosystems, assessing the role of underwater volcanism in global biogeochemical cycles, exploring novel biotechnological applications of volcanic environments, and evaluating the socioeconomic implications of volcanic activity on coastal communities and livelihoods. Public engagement and advocacy. Engaging the public, academia, industry, and policymakers in discussions about underwater volcanoes fosters awareness, collaboration, and informed decision-making. Public advocacy for marine conservation, sustainable resource management, and disaster risk reduction enhances collective efforts to protect and preserve underwater volcanic environments for future generations. Innovation and collaboration. Encouraging innovation and collaboration in scientific research, technology development, and policy implementation is essential for addressing emerging challenges and opportunities related to underwater volcanoes. Collaborative initiatives involving academia, government agencies, non-governmental organizations, NGOs, industry partners, and local communities can drive innovation, knowledge exchange, and capacity building in underwater volcanic research and management. Ethical considerations, such as respecting indigenous rights, cultural heritage, and traditional knowledge systems related to underwater volcanic regions, should be integrated into decision-making processes. Recognizing and valuing diverse perspectives, local knowledge, and community aspirations are essential for fostering inclusive and equitable approaches to underwater volcanic governance and conservation. Long-term sustainability. Achieving long-term sustainability in the management of underwater volcanic areas requires a holistic and adaptive approach that balances ecological, social, economic, and cultural priorities. By integrating scientific expertise, policy coherence, stakeholder engagement, and public participation, we can work towards a resilient and sustainable future for underwater volcanic environments and their associated ecosystems.